Hello, this is Mr. Stansbury. I'm going to take you through the notes on graphing polynomial functions. At the end of this, you should be able to say, I can sketch polynomial functions by hand and with technology, and also I can identify zeros and end behavior of polynomial functions. So I think the easiest way to figure this out is to just take a look at some examples. Okay, so we are going to draw a rough sketch of the following polynomials. So for A, we got negative 2x to the fourth plus 5x squared minus 3x plus 1. To draw a rough sketch, all we really need is the leading term. Okay. Here's what I look at on this leading term. We're going to look at the degree, which is 4, and we're also going to look if it's positive or negative. And that's all we need for a rough sketch. Okay? Because if you remember, here's a bunch of our different polynomials. We've got x squared, x cubed, x fourth, x to the fifth, and all the negatives. So here's kind of the big thing. Notice that all these over here on the right are negative, all these over here on the left are positive. Every one of these on the left, they all end up on the right side at the end. As x is going towards positive infinity, they all go up. And as it's negative, they all go down. Okay? So by looking at this here, since it's negative in front, I know that this polynomial is going to end up going down somewhere. Okay? And then what we'll want to do is we know, oops, I missed one. That this thing ends up going down. Okay? Now, whatever power it is, if it's fourth power, always take whatever power it is, 4, subtract 1 from that, we get 3. This thing should turn 3 different times, unless it's like a really perfect, like if it's a perfect x to the fourth or whatever. That's what these examples here. Oops, yeah. So like this is a perfect x cubed. It just goes right through. There's an x to the fourth. It just goes right through. If it's not perfect like that, then it'll actually have 3 turns. Meaning, here's what I like to do. Since I know it ends up going down because it's negative, I know that this is going to turn 3 times. So it's going to come up here. Oops. It's going to come up here. It's going to turn 1 time, 2 times, 3 times. So I know it's going to look something like that because it's going to have 3 what we call relative extrema, which extrema is basically maximums and minimums together. So it's got 1, 2, 3 turns. This is a rough sketch of the following of this polynomial here, because again it ends up with a negative, so it ends up going down. It's the fourth power, so it's going to have 1, 2, 3 turns. Okay, we can do the same thing with this one here. I'm just going to look at the leading term. It's positive, and it's x to the fifth. So since it is positive, I know that all positives end up going up. And if I go 5 minus 1, that gives me 4 turns. So I'm going to kind of work back to the left. So I always start on the right and work back to the left. It's going to take 1, 2, 3, 4 turns. So it's going to look something roughly like that, with a 1, 2, 3, 4 relative extrema, okay, or minimums and maximums together. Okay. If you think you've got this, pause it really quick and try C on your own, and then unpause it and check. But here we go. This one here, it is negative, so I know it ends up by going down, and it's going to have 7 minus 1. It's going to have 6 turns potentially. So 1, 2, 3, 4, 5, 6. Roughly looks something like that. Okay. Let's take a quick little comedy break.
What are you doing?
All right, only I can think of with that first dog is like maybe it couldn't see the ground and so it was confused. But anyway, I thought that was funny. All right. Last two examples. It says sketch a graph of the following polynomials that includes the x and y intercepts. So here's the thing. Here's the polynomial, and then here's the factored form of this same polynomial, because this will help us kind of figure out our rough sketch, and this will help us figure out where our x and y intercepts are going to be. Okay, actually just the x-intercepts. So same idea as what we did before, but this over here is going to tell us exactly where it crosses through the x-axis. Okay, so on this here, you can make a little bit more accurate drawing. So we know that all of these here, these are going to end up, we want these all to equal 0. And that's kind of like identify the zeros. We want each one of those to equal 0. So we want x plus 3 to equal 0, x minus 3 to equal 0, x plus 1 to equal 0, and x minus 1 to equal 0. So we've got 4 different little problems to solve. And if you'll notice here, hopefully you've figured this out by now, but if you haven't, let me kind of help you out a little bit. Look, we got x plus 3 equals 0. Subtract 3 from both sides. X equals negative 3. So it ends up, if it's x plus 3, our intercept's going to be at negative 3. It's going to be the opposite of this here, right? Add 3 to negative 3, and we get x equals 3. So that negative 3 turned into positive 3. Subtract 1 from both sides. X equals negative 1. Add 1 to both sides. X equals 1. So again, all of these, you just know, you should eventually get to the point where you're looking at this saying, oh, that's at negative 3. This one's at positive 3. This one's at negative 1. And this one's at positive 1. Okay, so those are going to be the spots where it intersects. We also want to go back here, and this is pretty important because this is going to help us figure out it's positive. So we know it ends up going up like this here. Okay, and it's going to have 4 minus 1. It's going to have at most 3 turns. Right? And then also this plus 9 tells us that it's going to end up crossing right through there at 9. Okay, so if we're just kind of sketching this here, we know it's going to come down, go through that, come back up through that, go through that, go through that, come back through there. Looks something roughly like this. This is a sketch of the graph, but it has the x and y intercepts. Okay? Same idea over here. Let's see, let's do this this part here. I'm going to go through and find the x-intercepts first, and then we can do the y-intercept, and then we can figure out where everything's going to go. So some people get tricked by this one here, negative x. That just means that x has to equal 0. So we know that there's an intersect here at 0. Now this is x plus 2, so that means it's going to be at negative 2, right? And then this is x minus 1, so that means there's going to be another intercept at positive 1. And this is x minus 3, so there's going to be another one at 3. Okay? This is x to the 5th, so 5 minus 1 gives us that there's going to be possibly 4 turns, right? And, oops, let's see, I forgot to put a dot on that one. So there's our intercepts here. Now, we know that this is negative x to the 5th, so we know it's going to end up by going down because it's negative. Okay. Oh, also, there's no constant in here, so plus 0, so that means there's our y-intercept is going to be at 0. Okay. Now, here's one big key on this one here. This one right here is what we call a double 0. Meaning, if it's a double 0, that means that I'm going to use this, it's going to bounce. It's going to bounce at x equals negative 2. So this one right here, this one's going to bounce off this last one. So we know it's going to go up, it's going to cross through this one, come back down through that one, back up here, and it's going to turn, and it's going to bounce off of this one, this negative 2, and then come back up. Whichever term here is squared, the x plus 2, so that means negative 2, it means it's going to bounce off of that point right there. Okay? All right, that's all we have for graphing polynomial functions. If you have any further questions, please feel free to ask. Thanks.